Hello, in this video tutorial, I will solve the first question in the free response questions of the AP Chemistry Exam 2023. Before we start the question, I want to stress at the point that it's written in your exam that the first three free response questions require about 23 minutes to answer. So you have to be careful with the time. And the rest of the questions from 4 to 7 are short questions that you need to spend maximum 9 minutes for every question. It's very crucial in the AP Chemistry exam that you show your work. If you write the correct answer, just an answer without showing your work or the steps how you reached the answer, no point will be rewarded. And it's written clearly for each question, show your work for each part in the space provided after that part. And when you do calculations, you have to show the method used, you have to show the steps so that you earn the full mark. Be aware that in every AP Chemistry exam, you have before the questions the periodic table, you have the formula sheet that you will be using it, and then the questions. So let's start. Manganese has several common oxidation states. Write the complete electron configuration of manganese atom in the ground state. So here we are looking for the electron configuration. You have the choice to write the normal electron configuration or the noble gas notation. You can do whatever you want. This is the Mn that we're looking for. So I've placed here the periodic table horizontally so we can see it. Here we need to apply Aufbau principle that says that when we fill the electrons in the orbitals, they must be filled from the lowest to the highest level. So in your periodic table, you have first 1 and level 1, 1s. In order to reach Mn, I'm gonna slide my finger through the orbitals that we go through. 2s2, 2p6. This is the area of P block. This is the area of S block. This is the area of D block. And this is the area of F block that starts after BA. Okay, but we're not gonna reach this part. So I repeat again. 1s2, 2s2, 2p6 all the way, 3s2, now there's nothing here, then 3p6 all the way, and then next you reach 4s2. Now always in the D, it's always one level minus 1. So if I am in line 4, I'm gonna say 3D. I'm gonna say 3D. So this is 3D1, but this is not Mn. 3D2, 3D3, 3D4, and 3D5. This is the correct electron configuration. You can also watch a video tutorial on my YouTube channel about those principles of Aufbau principle, Hund's rule, and the Pauli exclusion principle, and writing the electron configuration. So I'm going to write the answer: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Or I can simply write the noble gas notation. Argon is the last noble gas we have before reaching Mn atom on the periodic table. 4s2, 3d5. Now, just if you write this, you get 1 full mark. Now, if by any chance you write 3d5 and then 4s2, you will lose the mark, because here you are not applying Aufbau principle. You are not showing that electrons are filled from lower to higher energy level. Now, the next question: when manganese forms cations, electrons are lost from which subshell first? Identify both the number and the subshell associated and letter associated with the subshell. When atom wants to form an ion, it loses electrons, especially that this is a metal, so it loses electrons, and usually electrons are lost from the highest filled sublevel. So the highest filled sublevel, this is sublevel 1. These are sublevel on energy level 2. And here, the S and the P and the D, the sublevels of energy level 3. Since there is 4, it means that 3 is not the highest sublevel, and therefore the highest filled sublevel is the 4S and not the 3D, because the configuration ends with the 3D5. Okay, so 4S is the answer. Now question number 2, and this one earns 1 full mark if 4 and S are both written. If anything is missing, it's a 0 point. There are no half marks in AP chemistry. Now the next question. A student performs an experiment to produce a manganese salt of unknown composition, MnXClY aqueous, and determine its empirical formula. The student places a sample of Mn in a beaker containing excess HCl, as represented by the following equation. Now, if we look at this equation, we notice that the mass, whatever amount of matter of manganese that we have here, it fully changed or gave me the manganese that is in the compound MnXClY. Therefore, if I know the mass of this manganese, I can know the mass of this manganese in the compound. Knowing the mass, of course, it can take me to the mole, which is one more step. You have one more step after that to find the empirical formula. Now, in order to find the mass of Cl, we will see the data given. We cannot get the mass of Cl from HCl because this one is in excess. So not all the mass of Cl here is formed here. There's still some Cl remaining. So let's look at the next page and see the data provided. So here in this table, they've given us the mass of the beaker empty, the mass of the beaker and manganese. So if I minus those, I can get the mass of manganese. Hold on a second. And then mass of beaker and manganese and the Cl with it, MnXClY, after heating the constant mass. So if I minus those two, I can get the mass of Cl. Now let's see the question. Calculate the mass of Cl in the sample of MnXClY remaining in the beaker. Here, it's just a simple answer. You will write 62.673 minus 61.262 grams. The final answer, we have to follow the same significant figures of the numbers given in the question. 1.411 grams. 1 full mark is earned. Why? Because I am showing work and the question and the answer is correct. So any other method, it's going to be longer because I have to be careful and use the time wisely, but it will lead me to the right answer. Now the next question, calculate the number of moles of Cl in the sample remaining in the beaker. I have the mass of Cl, found it in part B. Now I need the moles of Cl. Please remember that in your formula sheet, you have this formula of mole equals to mass over molar mass. So you can use the help of the formula sheet. So now, 1.414 grams of Cl 1 mole of Cl over the molar mass of Cl. This is the conversion factor, gram of Cl. Why I wrote it like this? I can also simply write N equal mass over molar mass and write 1.411 over 35.45 gram, but I have to write also the units so that it reflects the conversion factor that I did over here. So now the final answer is 0.398 moles of Cl. You can write your answer like this. You don't have to follow the significant figures. Even if you write it 4.0 times 10 to the power negative 2, it will still be considered right. You will earn the full mark. So work is shown and the answer is correct. That's 1 full point over this part. Now, the student determines that 0.0199 mole of manganese was used in the experiment. So let's see now what we have. I have manganese and I have Cl. I have the mole of each one. I don't have to start from the mass because I have the mole already. They gave me the mole of manganese, 0.0199 mole, and I have the number of mole calculated just now of Cl. We need to use this data to determine the empirical formula of Mn. Now, when we learned about how to find the empirical formula, we always find the ratio between Mn and Cl, which is we divide by the lowest possible number, by the lowest number between them. So 0.0199 over 0.0199, that's a 1, and over here we get 2. This is showing your work. And here, because the question says determine the empirical formula, if you do not write the formula that I'm gonna write right now, you will not gain the mark. After writing MnCl2, 1 full mark is earned. Now the next part. The student repeats the experiment using the same amounts of manganese and HCl and notices that some of the MnXCl splatters out of the beaker. We lost some of the sample as it is heated for dryness. Will the number of moles of Cl calculated for this trial be greater than, less than, or equal to the number calculated in part C? Of course, the number would be less because we lost part of the sample. So the number of moles of calculated, number of moles of Cl calculated is going to be obtained. It's going to be lower than what we are expecting. So definitely the answer is going to be less. So this will decrease the calculated mass and eventually will obtain less dry compound, less dry solid. So here's the answer, less than if some of the mass of aqueous MnXCl is lost due to splattering, the final mass of the dry beaker and MnXCl will be decreased which will decrease the calculated mass and number of moles of chlorine in the dry solid. Now with this explanation you will earn a full mark because you said that it's going to be less than. The justification is the one giving you the 1 point. Now next part, another compound of manganese, MnO2, is used in alkaline batteries, represented by the following diagram. So as you can see here, this is a sealed closed battery and we have 3 reduction half reaction. Always when they give you the half reactions, they're going to give it to you in form of reduction. So electron is gained. Now you look at the potential in order to know which 2 half reactions to choose in order to get a thermodynamically favored reaction. So here's the question. Based on half reactions given in the table, write the balanced net ionic equation for the reaction that has the greatest thermodynamic favorability. In this case, we have to choose the highest one with the highest voltage and the one with the lowest voltage. With this selection, we will end up with the highest E cell voltage, because when we want to calculate the E cell voltage, it's going to be the voltage of cathode minus the voltage of the anode, E cathode minus E anode. With this case, the sign will switch, it will become positive because you're saying cathode minus anode, so it's going to be 0.15 minus minus. So if I take the 0.76, it's not going to give me the highest answer of voltage. And of course, as we will mention in class, that a high voltage, this one will work as the cathode, it will remain as a reduction, and the one with the lowest voltage, it will be the anode. So the 2 half equations, we have to show our work in order to write the final one. So it is 2MnO2. Never forget the physical states in the equation. 2MnO2 solid plus H2O liquid plus 2 electrons, Mn2O3 plus 2OH minus aqueous. And for the other one, it's going to be zinc solid, this one, but I'm going to flip it because this is going to operate at the anode. It's going to be an oxidation and not a reduction. Zinc solid plus 2 OH minus aqueous, zinc oxide plus H2O liquid, and 2 electrons. Now cancels out the electron as well, and now here's the final answer. 2MnO2 and zinc, Mn2O3 plus zinc oxide. I want you to see that all the components of this battery are solid, and this is something important. Now, we wrote the balanced net ionic equation, and that's it. This is what they asked. Now, the next question, they ask us to find the E cell of the overall reaction. Now, the formula of E cell is not given in the formula sheet, but You will have to remember that the E cell is the cathode minus the anode. E of the cathode minus E of the anode. Therefore, it is 0.15 minus negative 1.28, and the final answer is 1.43 volt. So here I will also earn, I forgot to put here one also full mark, I will earn 1 point for showing my work and for having the correct answer. Now calculate the value of delta G, the Gibbs free energy standard, in kilojoule per mole reaction. Now, the formulas of delta G are all given in the formula sheet. And I want you to see that this is kilojoule per mole reaction. Here I have voltage. In the formula sheet, let me see here, in the formula sheet, this one, the voltage is written here. 1 volt is joule per coulomb. So I can do a conversion factor, and the formula they are looking, we need to use it, is delta G and the connection between delta G, Faraday's constant, and the voltage of the cell. So everything is written, all the constants are given. The Faraday constant is coulomb per mole of electrons. And we have in this equation 2 moles of electron per mole of the reaction being transferred. So let's continue and write the final formula. So delta G is equal to minus NF, Faraday's constant, and the calculated E cell. So as I mentioned, the electron transferred is 2 electrons transferred. So 2 electrons, 2 moles of electron per 1 mole of a reaction. So here we have 2 moles, that's the N, of electron per 1 mole of a reaction, because I want the answer eventually to be per mole of a reaction. Now, we're done with the N. Now, Faraday's constant, it's always given to you in your formula sheet, 96485 coulomb per mole of electron. So here, more electron, they can cancel out. Now next, the E cell, the voltage calculated, 1.43 volt. Now the volt in the formula sheet is joules per coulomb. Now, my answer, I want it in kilojoule. So again, I need to convert this joule to kilojoule, which is divided by 1000, because 1 kilojoule is equivalent to 1000 joule. And like this, the units worked out, and the final answer is going to be minus 276 kilojoule per mole of a reaction. The answer is negative, which means this is thermodynamically favored and consistent with the previous parts. You can also see here how the units are cancelling out: mole, electron, coulomb, joule per joule. The only units remaining is the kilojoule and the mole of reaction. Now the final answer in the final question in this exam paper, here 1 full mark earned. So a student claims that the total mass of an alkaline battery decreases as the battery operates because the anode loses mass. Do you agree with the student's claim? Justify your answer. Be careful to the tricks in the exam. Yes, it is true that the anode loses mass, but also the cathode gains mass. And here you have a battery made up of everything is solid. solid, reactants are solid, products are solid as well. And whatever mass is lost, whatever mass lost in the anode, on the anode side, it will be gained on the cathode side. So overall, the mass of the battery will not change. It's a closed battery. So no change in total mass will occur. So keep that in mind. So I do not agree because the mass, the total mass, the mass of the battery will not change. So I'm going to write the answer. Disagree. The cathode gains mass. We know that. But also the anode loses mass. So the total mass of the battery will remain the same. Anyway, in a chemical reaction, you can also mention the law of conservation of mass. Reactants and products are all solids, and by the law of conservation of mass, in a chemical reaction, mass is conserved during a chemical reaction. Mass is conserved, and that's it. Here you earn a full mark. Thank you for listening.